Hello, everyone. Welcome to the 2026 UAF Arctic Innovation Competition presented by UAF Coal Mine. My name is Lael Barch, and I am a UAF College of Business and Security Management student studying business administration.
My name is Bella Ravana, and I am a UAF College of Business and Security Management student pursuing an interdisciplinary studies degree.
We are honored to be your MCs this evening for the second night of the main division semifinals. These are the top 10 ideas. 4 competitors presented last night. We will hear from 5 more presenters tonight. As a reminder, they are competing for cash prizes of up to $15,000 and 4 kicker prizes valued at $2,000 each. The Arctic Innovation Competition awards over $45,000 in cash prizes and awards, and this would not have been possible without the generous support of our many beloved sponsors. Founding sponsors have supported AIC and our Innovation and Economic Development mission since 2009. That list includes AEDC, Design Alaska, Doyon Limited, Fairbanks Economic Development Corporation, Kinross Alaska, Juneau Economic Development Council, and Northern Bank. Competitors are eligible for kicker prizes, regardless of their placement in the top 10. The Educational Legacy Fund, Alaska NSF, F-Score, Mount McKinley Bank, and RESPEC fund these $2,000 kicker prizes. The Alaska 529 supports the Cub and Junior divisions. They are providing 7 education-free savings plan scholarships at $2,000 each. The Classroom of the Future Award, one of my favorite awards, is announced and awarded at the finals. One teacher that the Cubs and juniors include during the submission process, who incorporates AIC in the classroom, is randomly selected for a $2,000 award.
Want to vote on your favorite ideas? Fan favorite voting allows you to select your favorite idea in each division. Recipients will receive $100 and, more importantly, a unique Lego trophy. Thanks to Chris Mayrock from Allstate for sponsoring this award. Cast your vote on the AIC website starting Saturday the 11th and closing at noon on Friday the 17th.
Tonight, we have an expert panel of judges joining us. I have the distinct pleasure of welcoming Jim Coley, the judges chair of the main division representing Mount McKinley Bank, Kathleen Hook from Doyon Utilities, Melissa Ray from GCI, Justin Seavey, a UAF alumnus and instructor representing our presenting sponsor, UAF Coal Mine, David Sandberg, also a UAF alumnus from Respec Engineering, Emily Winfield from Design Alaska, and one new judge joining the main division's panel, who is no stranger to AIC, Peter Webley from the UAF Center for Innovation.
The UAF Arctic Innovation Competition awards over $45,000 in cash prizes and awards, and could not have happened without the generous support of many sponsors, including our presenting sponsor, UAF Coal Mine. You are all invited to the 8-Star Event Center at 1 p.m. on Saturday, April 18th, for food, door prizes, and the last round of presentations.
Let's get started with the presentations. Each competitor has 5 minutes to present their ideas, followed by 5 minutes of questions from the judges panel. First up is Edmund Apasniok, my apologies, with Arctic Radiator Fin. We'll start by watching a short video about his idea. Edmund, when you're ready, please give me a thumbs up, and once the timer starts, we will begin your video. When the video ends, you may begin the spoken part of your presentation.
Edmund, please turn your video on and accept the promotion to panelists, and we will begin your presentation once you do.
I'm trying to. How do you start it?
Oh, you're good.
What?
You are perfect. Just let us start your video and then you'll be able to start your presentation. Give us 1 second.
I'm trying to start it. Ottawa.
um, add more heat to any given space. There's bare copper here, a good measure. For then 29 inches we'll do here. So I'm gonna cut this piece, whole piece here. They come in 6/8, 8-foot lenses. So it's measured here, 29 inches. And it's done. And I just take a like a long nose pliers, bend the rough edges there a little bit. And we're done. And all we have to do is slap on the usually they're 3/8 3/4 piping using impact driver, and just make sure it's all snug right there first, and it doesn't move. So I'll just go here right to the it called um, and you're done. And about inch from the edge there, and you're done. Here, about an inch back of the baseboard, and you're done. But usually 3 should work. But I'll put in 2 more just to have that snug fit to the copper tubing. You can see here, it just took me a matter of maybe 5 minutes to be done without.
Hey, can you hear me?
Yes.
Okay, I came up with this idea some 15 years ago. In one brutal year, the wind was brutal, 50 below, 50 knot winds, and no matter how insulated the house was, the wind was sucking out heat from the house, um, and the boiler system could not keep up with the demand of just barely hovering at 70 degrees, 69 degrees. It was brutal that year. So I looked around the house and there was bare copper pipe all over the house, as a modern house it was. But I thought if only I had some sort of fin that I could just slap on without turning off the boiler, draining the glycol, and and add more heat to any given space all around the house, from 1 foot section to 4 to 6 feet of bare copper pipe that was added. I went out with 110 feet of prototype, and I got this final product finally, and there it is. You see in the video. Thank you.
Thank you, Edmund. Sorry about those technical difficulties. Are you ready for some questions for our judges? Judges
Yes,
will
ma'am.
each get to ask a question in a particular order, starting it out with Kathleen, followed by David, and then Peter.
Good evening, Edmund. That is just a very cool invention there. How are you making that?
Currently, I kind of shelved the idea due to lack of collaboration with the manufacturer or the where it can be produced. I kind of shelved it for a few years, but now with this, I decided to submit it to AIC this year.
So you just have that one prototype that we saw in the video. You don't necessarily aren't making these anywhere and selling them to your neighbors?
No, nobody would afford it. Number one, you know, the similar ones out that made out somewhere in U.S. that cost $50 a foot or more. But with this idea, it's much simpler. Way to add any given space, like I said in the video, and that industry, when I researched it, was worth $1 billion, not just in the U.S. but across the world, as this would simplify during repairs and add more heat to like New York. I've seen folks in New York and at places where it's sorely needed without turning off the boiler, without draining glycol, without hiring a plumber.
Got it. Sure.
Which would cost thousands of dollars.
Well, thank you, Edmund. I'm not sure who's next, Peter or David.
I believe David is. So David, over to you.
Yeah. Thank you for your presentation, Edmund. Yeah, it looks like you are in Gamble. I had an opportunity to visit Gamble last year, and an innovation makes sense for performing repairs in a remote community where getting parts is really challenging. I did look at this, and I've seen them before. I think you mentioned there's products available. What really, I want to understand what makes yours unique. I see others that it's about a 2-foot clamshell that can be attached to a 3/4 copper pipe. They come in about 2-foot lengths, and they range in price between about $75 and $100. What I could see in the video, it looked like there's maybe more aluminum in contact with the pipe. Maybe that's better for transferring the heat. Maybe you could, if you could speak to what makes yours unique.
Yeah, this one's again much simpler, but what what I didn't have was a transfer heat radiation film that could be pasted or painted on, which when you put it, the transfer of heat from the copper pipe to the fins would be more efficient at that point. And I did make 110 feet of the prototype, but I mostly installed it in my home. But I do have about 10 feet of the prototype with me at this moment.
Okay. Thank you.
Thank you, David, and thank you, Edmund. So my question, thank you for the presentation, and yeah, having lived in Alaska myself for 20 years, I've seen the range of temperatures and conditions where the ability to adapt the homes and housing to be able to be most efficient is critical. My question is, how long does it take to make the prototype? Like, if you said, I want this house to be fitted tomorrow, how long would it take to make the piping needed for a property?
I did a contract out of fabricator out of Wasilla. I didn't have those numbers with me, but it took a little bit. I went through like 3 or 4 prototypes to make the final prototype that I have with me in the video. And they did, it didn't take overnight, but those guys understood what I wanted. It's a fabricator out of Wasilla. I forgot their name at this point.
Okay, great. I think we're close to time, so we all appreciate the presentation and congratulations for your presentation today. And we'll pass it back to the MCs. Thank you very much, Edmund.
Thank you very much.
Now we will move on to our second presenters this evening, Blaze Brooks and John Riddle IV, explaining their idea, drum ski. When you see your idea title and you are ready to present, give me a thumbs up to start the timer and we'll spotlight you. Blaze and John, can you please turn your camera on?
Yeah, sorry, we're just adjusting things on the screen. So are we ready?
Yep.
Oh.
Hello, my name is John Riddle, owner of Shake and Bake Coating and Blasting.
And this is Blaze Brooks, co-creator of the Drumski and owner of a local engineering company. We're here today to present Drumski, a solution designed to improve fuel transportation to remote Alaskan communities and cabins. This is a problem we've both previously experienced and we believe has a scalable solution. Next slide, please. In Alaska, fuel drums are critical infrastructure. They support heating, transportation, and survival in many remote communities. But from personal experience, the way we currently move drums is far from ideal. Last winter, I was part of multiple remote fuel hauling expeditions, and we consistently ran into the same issues. Sleds jackknifing into obstacles, drums shifting and getting damaged, and trailers failing under load. The image shown here shows a damaged drum that was only halfway through a 100-mile trip to Ween Lake, Alaska, which is just north of Mount McKinley. This drum was completely destroyed after flipping down the trail, and it also shattered the front of the plastic otter sled it's sitting in currently. This happened because the haulage equipment isn't designed for the task, and this is happening at scale across Alaska, and thousands of people are moving fuel drums every year, creating tens of thousands of hauls. This represents a clear opportunity with an estimated in-state market of 1 to 3 million with additional growth potential beyond Alaska. Next slide, please. Drumski is an innovation built by combining and improving 2 existing systems, a drum haul, which is seen at the top picture. The drum hauler safely cradles and uses leverage to handle the drum. And then the lower picture is an elevated snowmobile sled designed for efficient travel over snow. Our innovation is how these are integrated. We created a system that not only effectively transports drums, but also makes them easier to handle during loading and offloading. Next slide, please.
This is our current working prototype, which demonstrates the feasibility of the product. This design focuses on stability, control, and usability. It uses a rigid frame for strength, a ski-based platform for smooth tracking, and a secure mounting system to keep the drum in place. One key feature is that the frame allows the drum to be loaded using leverage, similar to a dolly, so the user can safely position a full drum. Once loaded, the skis maintain flotation and tracking while the rigid frame reduces unwanted movement. Overall, it creates a much more controlled towing experience and reduces operator fatigue, as well as environmental risks from spills. As we continue to develop the drum ski, we are planning many additional improvements, which include torsion skis to add suspension and improve ride quality, an optional wheel kit for use outside of winter, compatibility with storage box systems like the Action Packer, and a rear receiver to allow multiple trailers to be connected together. Our goal is to make Drumski a versatile platform and adaptable for different conditions and uses. Next slide, please. One of our key advantages is our manufacturing and durability. Through shake and bake, coating and blasting, we handle powder coating in-house, which reduces development costs, improves our product durability, and ensures a consistent quality. Shake and bake coating and blasting was created recently in 2025 and is currently developing manufacturing capabilities and a customer base. By powder coating the Drumski, we are preventing corrosion in harsh Alaskan environments, extending our product's lifespan, and giving it a clean, professional finish. Operating locally in the interior of Alaska gives us proximity to our target market and a strong understanding of our customers' needs.
Drumski takes a problem that people across Alaska deal with every year and provides a purpose-built solution. It improves safety, efficiency, and reliability when transporting fuel. Instead of working around the problem, we design something that solves it. And we can go to our final slide, and we're ready for Q&A.
Thank you, Blaze and John. Let's see what ideas our judges have, or what questions our judges have about your idea. Peter, Emily, and Jim will ask questions this round.
Hi, I think I'm on deck first. So I had a question about if you can go back to the slide with the picture. I'm not sure if that's an option. But do you have shocks on the ski legs? I couldn't tell in the picture. Maybe you said.
So the prototype we built just for like product testing and kind of an idea, we did not. We actually have just a vertical support that ties into a snowmobile spindle. But in the future, we're planning on using a torsion suspension system, and that's actually something I've looked in with different manufacturers in the lower 48 to find a torsion spring and a spindle that's compatible to get a suspension system that's kind of compact. And we're actually kind of reverse engineering off of the Polaris unit. We're kind of reverse engineering that system based off of that. So it's one of the things we're trying to advance and develop for our prototype.
Okay, and the reason I asked is it looks like it would have a relatively high center of gravity, at least compared to a sled, which was the example you showed in the beginning. Is tipping a concern, or have you done anything to mitigate that possibility?
So the ski stance, we're going to stance the skis out just a little bit around the drum. It's nice to elevate your load when you're towing, just so that way you're not getting snow packed into it as much. And in like snowy conditions, you can kind of ride over it instead of plowing through it. So that is the intent of actually raising the load up about 12 inches off of the surface. But yes, the ski stance is that's kind of, again, part of our torsion spring expansion, which is our next step in developing the prototype.
Great. Thank you so much. I think it's Peter next.
Yeah, I'm next. Thanks, guys, for the presentation. Great job. So my question, I live in Fairbanks, so I've not had to deal with hauling my own fuel into a community. Is that the typical drum size that you would want to carry? You spoke about a chain-based system, but is that what is typical for hauling? You showed the image example of something inside the sled. Are drums that are normally hauled different sizes, or are you going to have a model that can work for all hauling capabilities?
Yeah, so this drum size is your standard 55-gallon drum that you get oil in, or a lot of other products. A lot of people commonly use these drums, and a lot of them are reused and recycled old, car oil, motor oil. And actually, sourdough fuel is where we got a lot of our testing drums. When you buy fuel from sourdough, the bulk plant, you can get drums from them for free. So it's actually very common for people to use these 55-gallon drums.
Great. I'll pass the next question over to Jim.
Hey, good presentation, guys. Hey, I've spent a ton of time trapping and hauling stuff in sleds, and I understand a lot of what you're dealing with and trying to get stuff moved out there. And I guess my question, I'm looking at that, and my first concern is how are you going to make sure that the skis stay parallel? I know I've caught skis on my snow machine on all sorts of stuff when you're out there on it, and so I'm looking at that thinking, man, that's going to get torqued. It's not going to track straight. What are you guys doing to make sure that it stays that way?
So like if you hit something like an impact would tweak your ski, right?
Yeah, I mean a beaver fob or all sort. I mean, you're always running over stuff when you're out there. It's not a groomed trail. It gets that washboard effect to it and stuff like that. And I'm just like, I'm looking at that going, man, what's going to keep those tracking straight and not off to the side or getting turned or whatever?
So that's actually kind of a cool thing. Polaris, they have designed their adventure sled, and when you hit an impact, the skis are on a leverage arm, so they have suspension coming up, and that'll save you from a lot of the impacts. So when you hit something like that, the suspension will take the impact, and then you'll usually end up either cracking a ski, and then if you bend a component, obviously at that point you're going to have to replace it. But I mean, for cracking skis or the spindles, that's kind of a replaceable item. You want to?
Yeah, and our current prototype, what it features right now is it uses the same spindle and ski rubbers you'd find on your snowmobile currently, and so it allows the ski to flex, and pivot slightly.
Yeah.
Okay.
And also, the nice part about the skis is, like there's the track and the ski, different areas of the trail. So this is going to be tracking behind the ski stance. So it actually tracks the ski stance of the existing snowmobile. So they actually track really well compared to a flat bottom sled, which slides around a lot.
Okay. Yeah. And then again, like Emily said, suspension is a thing. I mean, on my machine, it was my spine. So yeah, I think you're definitely going to need it on that.
Yep.
Thank you.
Thank you, guys.
Oh, wow. Ran the time out.
All right, well done. Next, we will move on to our next presentation from Drini Palumbi, explaining his idea, the Arctic Heat Recovery System. Once you see your slides, please give me a thumbs up to start the timer, and you'll be ready to present.
We're ready to start. Hello, my name is Drini Palumbi, and I'm a mechanical engineering student at the University of Alaska Anchorage.
And I'm Vyosa Palumbi, and I'm also a mechanical engineering student.
Today, we're here to talk to you guys about the money that rural Alaskan families are burning up the stack every single day. Next slide, please. In rural Alaska, heating is survival, but heating oil costs around $8 to $15 a gallon. A typical family burns over 1,200 gallons a year and can spend around $10,000. When 30-degree cold water enters the boiler, it has to fire long enough to heat it up to 180 degrees Fahrenheit. 13% of that fuel energy and 13 cents off every dollar is wasted. Our system aims to recover that heat and use it to preheat the incoming water so the boiler does less work. Next slide, please.
The DCRA 25 report found that heating fuel averages $6.58 a gallon statewide, 73% higher than the national average. My hometown Bethel is at nearly $8 a gallon, and in Arctic Village, it's $15. These communities are locked into the previous summer's barge's price all year long. The average hydronic boiler runs at about 87% efficiency, but 13% of $10,000 is $1,300 a year wasted up the stack at around 400 to 500 degrees. And right now, nobody's recovering that heat on the residential scale.
Next slide, please. So how does our system work? Cold water comes in from the water main. It passes through our pipe jacket heat exchanger, where warm glycol flows around the water pipe and transfers heat through the finned wall. The glycol gets its heat from the flue collar. 400 to 500 degrees of waste heat passes through a stainless steel collar with a helical glycol pipe. The heat is then carried down to the pipe jacket. A small pump circulates the glycol and temperature sensors shut it down if the gas drops below 275 degrees to prevent acidic condensation. So now the boiler receives 60 to 80-degree water with a shorter firing cycle, less fuel burned, and fewer hours ran on the equipment. Next slide, please.
We designed 3 tiers. Tier 1 is the system that was just described. It saves around 5 to 10%, 75 gallons or $700 a year, and costs around $600. Tiers 2 and 3 add preheat buffer and storage tanks that reduce boiler short cycling and save up to 13% more. Next slide, please.
These cost estimates are with a 60% decrease in the estimated price to be conservative, but even if they were cut in half, the system still pays for itself in around a year and a half. Tiers 1, 2, and 3 would save around $700, $1,300, and $1,700 per year. Next slide, please.
Scaling this up, Bethel has about 2,000 households. At just 25% adoption rate, or 500 homes, that's 39,000 gallons of fuel avoided a year, 400 metric tons of carbon eliminated, and $315,000 returned to the local economy. Next slide.
Statewide, the target market is 20 to 30,000 rural homes with boilers. At just 10,000 homes, that is 750,000 gallons and 7,600 tons of CO2 avoided. That's equivalent to removing 1,600 cars off of Alaskan roads and over $6 million in annual fuel savings. Without the 60% derating factor, that's a potential savings of 1.5 million gallons of oil, $12 million, or 15,000 metric tons of carbon dioxide emitted per year. Next slide, please.
We built this system for the Arctic. Propylene glycol protects against freezing temperatures, and 316 stainless steel resists acidic corrosion. The microcontroller monitors flue temperature with automatic safety controls to shut the system down when needed. And this model is handyman installable in a couple of hours. Next slide, please.
So every winter, rural Alaska burns money up the stack. This isn't a new energy system, it's a simple add-on that immediately cuts heating costs for families who need it the most. We've done the engineering, we've 3D modeled the components and simulated the thermodynamics. The next step is to build a prototype and test it in real Bethel homes. We would pursue an Alaska Energy Authority grant to help make that happen. Less fuel burned means less money spent, longer equipment life, and cleaner air. That's the Arctic Residential Boiler Economizer. Thank you.
Well done. Justin will start the judges' questions, followed by Melissa and David.
Thank you guys for your presentation. I think this is a very, very interesting idea. I want to clarify, so you're talking about something that you can retrofit an existing system. This is not like this is something that's bolt on. It's not something you have to pull the existing system apart and install new equipment. Is that correct?
Yeah, for the most part, the most invasive it would be is we would have this this pipe jacket that you would connect to your water main, and this is just a 3D model of it. And then you would have to take out an insert on the flue collar in order to insert the glycol pipe. But we do have a kind of gasket design or a pipe clamp design to keep the pressure still constant, so there's no back pressure in the pipe. But it's meant to work with existing boilers. That's correct.
Cool. So you mentioned the water main. Are you predominantly preheating the makeup water, or is this preheating the circulating water as well, the recirculating load as well?
So it is both, and that's where tiers 2 and 3 come in to help with the recirculating water as well.
Okay. And then I think my last question, and then I'll kick it over to the next judge, is with the flue collar, have you considered the impact of changing the cross-sectional area available for the flue gases? And like, can you use the same size chimney stack, or do you need something bigger? Can you speak to that?
Yes, we've been working on it. A lot of the main problem is we don't have real world data to back it up yet, which is where the pilot would come in. It would validate how much it affects the pressure and flow. A lot of modern boilers have a fan that helps with the flow, but those would just come with the prototype testing.
Thank you.
Of course. Thank you.
I think I'm up next. This is fantastic. Thanks, you guys. Great presentation. I really enjoyed your slides. You answered my question right away. I was going to ask you about return on investment, and I see what's going up the stack, $1,300. And I think you said the cost of this is between 500 and 1,000. Was that right?
Yeah, that's the estimate right now. Once we make our first prototype fully, we'll have a more realistic estimate, and producing them in bulk would become cheaper.
Okay, so I just have a couple of questions. Let's see, 2 minutes. We talked about kind of bolt on. So there's no modifications, no permitting to consider, no safety issues, fire hazards, et cetera, with kind of bolting on. I'm concerned about the gasket. Is that any issue to be concerned about?
There are a few permitting things that we would have to sort out. We do have a list of everything we'd have to get covered, but it's all in the plan. That's definitely something we're thinking about taking care of.
Okay, and my last question is there anything else like this on the market, or is this new and novel?
So right now, the margins are too small for residential economizers, which is why I think a lot of companies have avoided this. There are residential or commercial economic economizers that cost $5,000 to $50,000. You need a crane to install them. They're massive. So there's nothing small scale in any patent database that we've looked at. So that's why we decided to go with this idea.
Perfect. Thank you. I will kick it over to the next judge.
Hey, thanks for the great presentation and great job choosing engineering for your education, future careers. So going back to thermo, you're changing your delta T on your water. You're reducing the amount of energy basically required to heat that water. Then you're looking at maybe the secondary effects of doing that, what that does to obstruct the flue gas, what that might do to the temperature of the flue gas, and you don't want to hurt the boiler either. So you don't want things coming in to get too cold. My question, I'll make it simple, is how do you regulate the flow to guarantee that there's no condensation or corrosion risk to the boiler?
Thank you. Yeah, so we would have two thermocouples. They're just temperature sensors at the base of the collar and the exit. And if the gas is exiting at 275 or lower, it shuts off the glycol pump. And that's with the 60-degree buffer. So heating oil type 1 starts condensating around 220 degrees. So there's a big margin of error there. And all that happens is the glycol just sits in the loop once it shuts off.
Great. Well, thank you.
Thank you.
Thank you, everyone. Let's take a moment to highlight our kickers, which award $2,000 each. First up, the well-known Arctic Kicker, sponsored by Respect Engineering, who specializes in innovating mission-critical solutions that enhance client success through integrated consulting and IT services. Alaska Student Kicker, sponsored by Mount McKinley Bank. Did you know that Mount McKinley Bank is the oldest and largest local financial institution in Fairbanks? The Climate Adaptation Kicker is sponsored by Alaska EPSCoR. It was created in 1979 to identify, develop, and best use the state's academic, science, and technology resources. Lastly, the Sustainability Kicker, sponsored by the Educational Legacy Fund. The Educational Legacy Fund supports organizations involved in public, STEM, and educational experimental funding. Thank you, everybody.
All right, next up, we will move on to Petra Illich with Helping Our Farmers, the Alaska Rhodiola Project. Remember to watch the countdown clock. Once you see your slides, the virtual stage is yours.
Okay. I'm ready. Hello, everybody, and good evening. I'm Dr. Petra Illig, the founder of Alaska Rhodiola. Thank you for this opportunity to share with you what we do, which is to work with Alaskan farmers cultivating a new crop called Rhodiola rosea. Our goal is to put money into their pockets by helping them cultivate the highest quality Rhodiola rosea on the planet. Next slide, please. Farming is hard, and it's especially hard in Alaska. Our farmers in general don't make that much money. On average, $40,000 to $50,000 a year. Their profit margins is very slim because it's expensive to grow food here, as most require greenhouses and high tunnels to extend the growing season. One solution is to cultivate a crop that actually grows naturally in the north, such as rhodiola. It could provide enough income to make growing food more affordable. Next slide, please. Rhodiola rosea is a medicinal plant well known to indigenous people of the Arctic. You can see its natural habitats on this polar projection map. Traditionally used to improve mental focus and physical stamina for athletes and warriors, it is now mainstream in herbal medicine for its ability to counteract the negative effects of stress. It is known as the powerful adaptogen and antioxidant, and we discovered that it actually likes growing here. Next slide, please. For the past 15 years, we've been helping farmers learn how to cultivate it successfully. There are now at least 8 growers, with more coming online every year. It is a high-value crop, capable of bringing in $100,000 to $150,000 an acre, and with prices steadily rising due to its increasing popularity in the dietary supplement industry. This offers Alaskan farmers an income stream that may result in them being able to grow more food. Next slide, please. Like most crops, there is a lot of testing that goes into producing a quality product. Rhodiola requires specialized, rather expensive lab testing to determine harvest timing and crop price. To determine if a crop is ready for harvest, the roots need to be tested for the concentration of a key ingredient called rosavins. If too low, you just wait another year. After harvest, though, in order to determine the market price, the roots need to be tested again, this time for 2 substances, rosavins and salidroside. Therefore, there are a minimum of 3 different tests involved in producing a harvest. Next slide. These tests generally run at about $350 to $500 per test and may take up to 2 weeks for the results to come in, since currently the samples are shipped to labs outside of Alaska. A farmer can therefore spend between $1,000 and $1,500 per prospective harvest. This would be prohibitive for the small farmer, and it can take up to 2 weeks for the results to be available, making real-time harvest decisions difficult. Next slide. Since our company, Alaska Rhodiola, is in the business of producing rhodiola root extracts, we have the expertise to do this lab work for the growers here in Alaska for about $100 per test and deliver the results within a couple days. This would be a 70 to 80% reduction in growers' costs with an acceptable turnaround time. As more growers come online, the demand for this service would increase. Next slide, please. To accomplish that, we need a high-performance liquid chromatography machine, HPLC. Although there are many other types of analytic equipment, this is the most reliable and affordable option and the one most commonly used. A small refurbished machine might be found for 25 grand, but it comes with problems if it's not new. We would prefer a medium-sized, preferably new machine, which runs about $75,000, and maybe with some other added features, $100,000 with some of the accessories. We are currently in the process of fundraising for this equipment, and an award from AIC would be greatly appreciated. The farmers would appreciate it too. Next slide, please. Myself, Al Poindexter, who is my business partner in Anchor Point, and Brittany Mosel, our lab manager, thank you for your attention. Last slide, please. I'm open for questions.
Thank you, Petra. Now, Kathleen will start the questions, followed by Justin and Melissa.
Well, thank you. I'm not even aware of this product. This is very interesting. This doesn't grow in the wild at all? This is strictly grown on farms?
There are many rhodiola species. There's about 90 plus rhodiola species, and this particular species, Rhodiola rosea, doesn't seem to grow naturally in Alaska. Its sister species, Rhodiola integrifolia, grows in many different places. You can find it at Hatcher Pass, also medicinally used traditionally, but it has different features. So in that map I showed you, it was sort of a conglomeration of all the different rhodiola species. But the best species, the best rhodiola root for botanical purposes comes from wild harvest in the mountains of Siberia and Central Asia. And if I may throw in there, botanical companies are shifting to cultivated sources because in the wild, this plant can be, it grows so slowly, it can be many decades old when it's harvested, and it's a destructive harvest. So it's the root that's pulled up, the plant is destroyed. And so it has led it to be considered an endangered species in the wild. So more and more places where it can be grown are popping up. And Alaska is the perfect place for it because it's a subarctic plant. You really can't grow it in the lower 48. Maybe up in the hills of Vermont or in the Rocky Mountains, but nobody really farms there. This is the ideal place for us to grow this plant.
Thank you. It looked familiar. That's why. But
yeah.
I have been.
Yeah, the other one is much smaller.
Got it. So, but what I'm trying to understand is, what is the novelty here regarding your activity? I see that is the lab method that you're testing here different than what happens elsewhere in the country? Or is it just a matter that we're moving that lab test closer to the source, the farms here?
The farmers need rapid turnaround at a reasonable price. So when a farmer wants to know, can I harvest? It looks like it's going to be pretty good weather this next week. They need to know, is it worth harvesting? Are the concentrations of rosavins high enough? And they have to be at least over 1% to be even of value. And if you wait 2 or 3 or 5 weeks later, the rosavin concentrations may dip. So they need those results quickly. And if you have to ship it out to a lab and wait 2 weeks for those results, that window of harvest may have shifted and the farmer may not be able to do it.
So just interesting, these compounds, they go up, they increase, and then they can decrease. It's not like it gets more concentrated each time.
The plant has to be at least 5 years old, 4 to 5 years old to be mature enough to be harvested. And then once they're mature enough, you have to kind of test to make sure, is it good this year? Is the timing right?
All right, I'm hogging you too much, Petra. I'll turn you over to
No, that's okay, Kathleen. I think I'm next. It's very interesting. I appreciate the, obviously the timeliness of it. You talked about the HPLC equipment, and you want kind of that medium to large size at 75,000. How long will that last you? If you've got 8 growers now here in Alaska plus yours, how long before you would have to buy a new or better piece of equipment? What's your kind of cost looking forward?
They last for a long, long time, especially if it's new. That's why we're a little hesitant with refurbished equipment. And it's not just the growers wanting to know, can we harvest now? There are many other ways that we would be using this equipment. I've been doing several years of research for learning through USDA grants, for learning harvest timing with fields at the University of Alaska Fairbanks Experimental Farm, for example. We could be doing for our internal research and our product quality assurance, we could be doing dozens of these tests throughout the year for various reasons. This is just the one focusing to help the farmers.
Okay, Justin, talk quick, you're up.
Well, I think I just have one question. This testing, is there like an ASTM standard test? Like, are the certifications required? Or can anybody do this kind of test?
Well, it requires having the equipment and the standards against which that spectrometry is compared. Yeah, these are perfectly standard chemicals that are used.
Thank you.
Thank you, Dr. Petra.
Thank you all. Our next competitor this evening is Anthony Van Weel, showcasing field weave. Anthony, ensure you can see your slides and give us a thumbs up before starting your presentation.
Can you hear me?
Yes.
Okay, good. I'm ready. Hello, I'm Anthony, and I'm the creator of FieldWeave, a platform for affordable high-resolution imaging. Next slide. So, what are the limitations scientific imaging currently faces for large samples specifically? Imaging in most labs is currently done manually, resulting in limited throughput and inconsistent data quality. And it is also a repetitive task, which is a perfect candidate for automation. So why don't they currently automate their imaging? Next slide. As it turns out, automation is expensive. The typical flatbed scanner that is currently used in labs costs over $4,000 brand new, with the secondhand market being able to be gotten for as low as $600. With automated imaging solutions that are to get the really high resolutions, those cost over $40,000. The flatbed scanners typically resolve a maximum of 2,400 dpi or less, even when they claim to resolve up to 10,000 dpi, as they are limited by their optics. The automated imaging typically resolves a DPI of at least 19 thousandths. So why would we want images with such high DPI? Next slide. Well, once you get past 10,000 dpi, you start being able to resolve individual cells, allowing for advanced analysis of samples that would traditionally require X-ray imaging, such as blue intensity measurements. Next slide. FieldWeave is a low-cost, high-resolution imaging platform that combines software and off-the-shelf hardware to enable high-resolution imaging for as little as $600, achieving a DPI of 11,500. However, due to its modular nature, the motion system, camera, and optics can be switched out, allowing you to use microscope objectives, allowing you to achieve a DPI of 84,632 with a configuration that costs less than $2,000. FieldWeave achieves this lower cost by using cameras with smaller image sensors, resulting in a lower cost, but also a longer imaging time as they're imaging a smaller area. This is the reason why that the $40,000 machines don't use these smaller cameras, because it just takes longer to take the pictures. Next slide. So how well does it work in practice? Well, I've been working with the Environment and Natural Resource Institute at UAA to verify the platform in a lab environment. And what we found was that the imaging throughput increased 7 times and enabled plants to re-image over 2,000 samples at a higher resolution. However, when testing, we do not run a full batch, so the actual maximum throughput is higher. Currently, they are no longer bottlenecked by the rate at which they can image samples, but rather the rate in which they can analyze the imagery instead. Next slide. So what are some ways that FieldWeave improves upon the existing solutions? Well, using machine vision, FieldWeave is able to determine when samples are in focus and only take pictures then. This results in a 76% decrease in the number of images taken. In addition, through the use of an AI image segmentation model, which can be trained on samples, is able to further reduce the imaging time by only focusing on the parts of the sample that we are interested in. Next slide. In addition, just like the automated solutions, FieldWeave integrates the entire imaging pipeline from capturing the images to focus stacking and stitching them together, resulting in reduced post-processing times, as it is able to start as soon as the images are done being captured, as opposed to having to wait until a person is available to start the process. Next slide. So where would FieldWeave be useful? In dendrochronology, high-resolution imagery is needed of tree core samples ranging from a few inches in length to well over a foot long, and tree core cross-sections, which when you cut down a tree and take an entire slice of it. With FieldWeave, labs are able to break even after imaging just 240 samples. For reference, labs typically go through well over 500 samples per year, with some high throughput labs going through over 1,000. In geology, thin sections are typically imaged with a flatbed scanners or a traditional DSLR camera if a lab cannot afford a dedicated imaging machine. Otherwise, they're sent out to a third-party service. With thin sections, you would break even after only 16 samples if you were to get them imaged at 10 times magnification through a third-party service. Meanwhile, for museums, this will allow them to image their collections at resolutions that would previously be considered unfeasible due to cost. Next slide. Overall, FieldWeave achieves high-resolution imaging at a lower cost than the traditional solutions currently used, while matching, if not exceeding, the capabilities of the automated imaging solutions on the market. Thank you for your time.
Thank you, Anthony. Are you ready to answer the judges' questions about your idea? Jim will start, followed by Emily and Kathleen.
All right. Well, it looks like my video got shut off. So, oh, there we go. Hey, well, quick question. Great presentation. I guess my initial question on this is, so is this something that you actually then attach to like a, microscope or something that's amplifying that? I wasn't really sure how that actual worked.
So this is a program that you can go and connect to the motion system and the camera, and then it'll automatically go and control that to go and take the images and
Okay,
process them
so
afterwards.
software, not hardware. Okay.
Yeah.
Alrighty. Perfect. Thank you. And then I guess my question is then, software, so you can probably either patent that or whatever. So have you done any of that yet or copyrighted it or protected it, or is this out there open source where somebody else could grab it and take it?
So currently it is open source under the, I believe it's the LGPL license. However, I am planning on having a paid binary, as I know that university labs, you can't always just go and download whatever programs you need to build the program. So having a binary that they can just go and purchase and be able to immediately use is a is the main method of monetization.
Okay. All right. Emily, I'll pass it along to you.
Great, thank you. So you sort of summarized at the very end what my question was, but I just want to make sure I understand it correctly. So it sounds like the primary benefit of your idea here is that what you can do with it would cost significantly more elsewhere. Um, so is the technology available elsewhere and just at a higher cost, or do you have new technology in addition to reduced prices?
So all of the technology used for this is technically available for free, except it's not like all things that you can just go and work together. Instead, so what this does is it gathers all that together and puts it into one platform that it can go through the entire process of imaging them. However, the paid automated solutions, they do actually rely on software that is no longer produced, like the Giga Macro, which on the side where I was showing the machines, that was the one all the way on the right. That one uses a program called AutoPano Giga, which got shut down by GoPro back in 2018, and as such, improvements on that software is no longer possible.
Oh, interesting. Well, thank you so much. I'll hand it off to Kathleen.
Well, Anthony, this is interesting. I'm holding on the edge here to make sure I understand. So tell me a little bit about. I see how you are super smart and know how to work this, but for someone that you're selling this to, how much human oversight does it take? Are there firmware or software updates, recalibration? How do you see this as a long-term operation for the person who wants to use it?
So that was one of the things that I was taking into consideration when building it, as some of the feedback that I got from the researchers at UAA is that the current machines they use, they will have some sort of like very step-by-step process that you must follow to the letter, or else the entire thing just doesn't work. what I've done is I've actually integrated the instructions for how to do things directly into the program. So for calibrations, there is an entire page dedicated to the calibrations in which you can then start them, and it'll give you a guided step-by-step process for how to do them. In addition, the setup time is only around 2 to 3 hours from opening up all of the equipment required to build this to actually having a working prototype. Well, I shouldn't say prototype, a working product. Or if you're going for the version capable of using a microscope objective, it takes around 6 to 8 hours.
And then long
Overall,
term, so once it's up and running, are you going to need upgrades? How do we do that?
So once it's up and running, all you really just need to do is lubricate the various axes, which takes about like 15 minutes once every 3 months. And for actually running a batch, from what I found, it takes only 5 to 15 minutes to go and get all the samples entered into the system. And then you just hit start, and it'll automatically just keep imaging them. And if something's like, say, a power outage happens, due to the physical limits on the machine, even if the x-axis falls, it will not hit your samples.
Okay. Thank you, Anthony. Few minutes left. Anybody else?
Good.
Yeah,
Well,
great
thank you very much.
presentation.
Thank you.
Appreciate it.
A friendly reminder that fan favorite voting starts on April 11th at 8 a.m. and ends on April 17th at 12 p.m. You can vote for your favorite idea in each division. Go check out the competitors' videos on the AIC website on Friday, April 11th.
As we wrap up the main division of semifinals this evening, I want to remind everyone that you're all invited to finals on Saturday, April 18th at 8 Star Event Center. There will be door prizes, food, and interactive activities for all ages. Come and support local entrepreneurs from 1 to 5 for usability finals and award ceremony.
Just a quick reminder to our judges that we are taking a 10-minute break and will gather back online for deliberation using the new Zoom link. And thank you, competitors, for your presentations and judges for your brilliant questions. It is a huge deal to make it into the AIC semifinals. We appreciate all the hard work and creativity you put into your ideas. Plus, you all did a fantastic job presenting. Thank you all, and good night.
Record.